All right, here's our function, and we are going to be graphing it. First thing we're going to do is answer a couple questions before we graph it. Describe the end behavior of this function. Now, to describe the end behavior, you have to find the degree and look at the a value, the number, the coefficient, the lead coefficient. So, my lead coefficient is a positive 1. So let's mark that down. For the end behavior, it helps to know my a value, which is my lead coefficient, is a positive. I don't care what number it is. I just care if it's positive or negative. The next thing we want to look at is, what's the degree? Well, to get the degree, you add up the powers. So the power on this x is a 1. The power on this x plus 3 is also a 1. And the power on the x minus 4 is also a 1. So if you want to, you could put little 1s here. Or just understand those are all 1s. So to get to the degree, you go 1 plus 1 plus 1. You add all the powers up. That would give you a 3. What that means is it's a third degree. Okay? So a third degree polynomial would mean, is that odd or even? Let's think. Odd or even? 3 is an odd number, so this is an odd degree. We're going to keep that in mind. It's an odd degree polynomial. Alrighty, so what does odd and a value positive mean? Well, that describes the end behavior. End behavior is, what's the graph doing on the right edge and on the left edge? So over here, the a value tells us what's happening. The a value tells you if you're going up or down to end with. Since our a is positive, that means it's going to be going up over here. So my end behavior is going to be going up on the right side. Now, so I'm going up over here, okay, but the odd tells us what the other side's doing. Odd means it goes the opposite direction. Even means it goes the same direction. So if this is going up over here with an odd function, it's going to be going down over here. So what that means is this graph will look like this on this end, and it'll be going up on this end. So that's kind of how we want to know. We want to put this right here. It's going to go up on the right and down on the left. That was what an odd looks like. And a positive a value tells you you're going up on the right. If your a value is negative, you'd be going down right here. And so this side would be going up with an odd function. So the next part of the question is, list the zeros of the function. I have the end behaviors, now I want the zeros. And the zeros deal with these numbers right here. So for the first 0 is, what would make x 0? Well, that would be 0. Because that's really just x plus nothing. X is really x plus nothing. So I'm going to call that, my first 0 is going to be 0. For this one right here. What would make x plus 3 0? What would you put in for x to make it 0 right here? Well, wouldn't negative 3 plus 3 give you 0? Mm-hmm. So the next 0 would be negative 3. And my next 0, what minus 4 would give you 0? That would be positive 4. So the basic shortcut is, isn't it always the opposite of these? And if there's nothing on it, isn't that a 0? Because really you have x plus nothing. So we have 3 zeros. Can I now plot those on my graph? I have a 0 at 0. I have a 0 at negative 3. And I have a 0 at 4. Those are my 3 zeros. And now we're going to play connect the dots to make the graph. Okay, so let's connect the dots. I need to, from here, I'm going to go and run into this dot. So how does it go through that dot? You look at the power. So negative 3 came from right here. Wasn't the power a 1? So what that means is my graph is going to go straight through right there and get down to here. So it's going to go straight through and try to get down to there. So it's going to boom, like that. Now from the right side over here, I'm going to cross this 4. 4 came right here, and that's a 1 as well. So 1 power is straight through. So what that means is I'm going to come and go straight through. So let's double check. They both had a power of 1. So both of these dots should be a straight through, and they go to the end behavior. You always must start on the edges. If you don't start on the edges, you won't know how it starts. And then you come to the middle. Now, what is the power of the x? This one right here? It's also 1. Now, the question is, does it go this way or this way? Well, in order to connect this red line to this red line and go through here, wouldn't it have to go at this angle, not this angle? It wouldn't make any sense. So if you think logically, wouldn't it have to come like this and like that? It wouldn't make any sense to go this way. Let's double check. They all have ones, so they're all straight through. Did we go straight through, and straight through? Is our end behavior positive, meaning is it ending at the positive? And is it odd, meaning you go opposite directions? Everything checks. We are good. Alrighty, here's our next one. A little bit more stuff going on. Let's find our degree. So this one wants the degree. Our degree is you add up the powers. So let's put a 1 right here. What's 3 plus 1 plus 2? 3 plus 1 plus 2 is 6. So this is a 6th degree polynomial. We've got a 6th degree polynomial. All right, next question is what's the end behavior? Well, the end behavior depends on the degree as well as the a value. Now, our a value is negative. We don't care about the 2. The 2 just says it's stretched. So the a is negative. And real quick, what is 6? It's 6 odd or even. 6 is an even number. So let's write that down. It's an even, and it has an a value that's negative. So let's think about how the edge of this graph will look. On this edge, since it's negative, doesn't that mean it's going to be going down? Negative a value means this edge will always go down. So I know it's going to look like that. But what would this side look like? If it's even, doesn't that mean it's going to go the same direction? So that means the left side is also going to be going down. So it's also going to look like that. So that is what my graph will look like on the edges. So I can go over here on my graph and quickly kind of go, okay, I know my graph's going to be going down over here, and it's also going to be going down over here. So I know that's how my graph's going to end on both sides, which will help me sketch it. Alrighty, let's keep working on this one. Next thing, let's find the zeros. It doesn't ask for zeros here, but hopefully you can tell what makes this 0. That looks like a -3. Okay, that would give me -3. What would make this 0? A +4. And what would make this 0 right here? A +1. So those are my 3 zeros. And now I got to figure out how I go through those zeros. So let's start with this side right here. How do we go through the -3? So that would be this power. That's a third power. A third power is telling us we're going to go through here with a twist. But we're starting from the bottom. So we're going to start from the bottom and have a twist. So what that look like is you're going to start from the bottom and have a twist. That's what it's going to look like. So now we kind of connect this, and now we have the twist from the left side. Now from the right side, we're starting down here. And what is the 4 telling us to do? The 4 is a 1, which is a straight through. So what that means is we are going to be going from down here, we're going to do a straight through. So we have the left and the right. Now we got to figure out how that middle 0 reacts. So that is the 1, which came right here with a square. So that means at 1 we're going to bounce. Now, since these are both on top, aren't we going to bounce from the top, not the bottom? Since these on both sides are on the top of the graph, top of the x-axis, we're going to bounce like this. So what I'm going to do here is I'm just going to draw my little bounce and then connect the dots to make my curves. So I just kind of go, okay, make a hump and make a hump. And there I go. I have my zeros. I have a twist at -3. I have a straight through at 4. And I have a, right here, I have a bounce at 1. And my end behavior or what I wanted. And I now have a sketch. I don't worry about how high or low the bumps are. I just care about my x-intercepts, as well as I care a lot about how I go through. Because we are just sketching this graph. We are not graphing it, we're sketching it. Good luck with it.